Hi, so this lesson is all about finding a lower bound on the travelling salesperson problem. So hopefully you've watched the others where we've used two different methods to find an upper bound, and we've chosen the least one of those. I think that will all make a bit more sense when we go through a full question. But today's lesson is all about finding a lower bound. So this isn't going to come out with a Hamiltonian cycle. So our optimal solution for the travelling salesperson problem does have to be a Hamiltonian cycle. So it does have to involve every vertex being visited once and only once. But our lower bound isn't necessarily going to come out with one of those. But all we're trying to do is minimize the range of our possible solutions. So let's think about how we do that. I've got this complete graph here. So we're going to start off thinking about a complete graph where all the vertices are joined to all the other vertices, just to make it as simple as possible. And then afterwards, we'll think about finding a lower bound on an incomplete graph, because that's best done using a distance matrix, so a matrix of least distances. Just because it saves you kind of drawing over the graph and changing everything. So to find a lower bound, we choose a starting vertex. So the question in the exam will probably tell you what one to start with. So we're going to start by deleting A. Okay, and what that means is that we delete A and we delete every single edge that links to A. So I'm just going to scribble those out so that we remember not to use them. Okay, and then we find a minimum spanning tree joining all of the remaining part of the graph. So you can use prims or Kruskal's to do that. I'm going to use Kruskal's. So the shortest arc is that one there, and then that one there, and then that one would make a loop. So I want to go for this one here. So that blue minimum spanning tree there joins the remaining vertices, and then once we've got that, we need to join back in the vertex that we've deleted using the two shortest edges that come from it. So it would be the two 4s that we'd use here. So that one there and that one there. So that would be my lower bound when I delete A. So that's got a weight of +3 +5, so 23. Okay. And then if we're going to do this properly, we need to go through that process again, deleting B, and then we need to do it again, deleting C, again deleting D, and again deleting E. So what I'd like you to do today is to go through and delete those vertices in order. And I'd like you to add a Google comment, a private comment with your answers for deleting B, deleting C, deleting D, and deleting E for the total weight of the lower bounds in that question. Okay, and then tomorrow, what we'll do, so it's quite a short task today. Tomorrow, what we're going to do, tomorrow's going to be quite a long task. It might take more than just the one lesson, because I'd like to go through a whole exam question where it's not a complete graph, and so we have to use a table of least distances, and then we actually end up finding a proper solution.